I'm Luca Congedo and you're watching From GIS to Remote Sensing. This is the second basic video tutorial about the processing of a Sentinel-2 image from download to classification. So, the first step is to download the Sentinel-2 images. We have these buttons here, and also in the SCP menu these functions here. We should select download Sentinel-2, and the main interface window will open. So this is the interface for downloading Sentinel-2 images. We should enter here username and password according to the service here. And at the moment, with the SciHub Copernicus, we should enter guest as a username and guest as password. Now we need to set the search area. In general, we could click this button and then with the left click and the right click define the upper left and the lower right corner of the area. But now enter these values. For the upper left longitude, enter 12. For the latitude, 42. For the lower right longitude, 13. For lower right latitude, 41. And then click the Find button. After a few seconds, you'll see that the result of the query will be listed here. All the images in this area will be listed. In particular, in this tutorial, we are going to use a specific image acquired in May 2016. So in date from, enter 2016 5/6. And also the same date in the field 2. This way we are narrowing the search and we'll get only the images acquired in this date. So as you can see, these are the granules or tiles of the image acquired on the 6th of May. You can see here the zone. We should select the zone 32 TQM, which is an area near Rome. So click this button to download the image preview. Then in download options, we should uncheck the bands that we are not going to use, band 1, band 9 and band 10. We should leave checked this option because we are going to download only this image with the preview loaded in QGIS. Uncheck also the preprocessed images and load band. Click this button here, select a directory where images will be downloaded, and click OK. As you can see, the download will start. When the download is finished, we can see that in the download directory we have all these files, JP2 files, which are the Sentinel-2 bands. Now we are going to convert the Sentinel-2 bands to reflectance. In particular, click this button here, Preprocessing, or select from the SCP menu, Preprocessing Sentinel-2. The main interface window will open and you can see here directory containing Sentinel-2 bands. Click this button and select the directory where all the bands were downloaded. Here the JP2 files are listed. we should check also apply it as one atmospheric correction, which is a very basic and simple atmospheric correction, and uncheck create band set because we're going to define the band set later. So now we can click run, define an output directory, and click OK. The conversion to reflectance will start. After a few minutes we'll have the converted bands here loaded in QGIS and converted to reflectance. So this is a very large area. We need to clip the data to our study area. So we are going to use the tool clip multiple images from the preprocessing tool. So select clip multiple rasters, and in the main interface window we should click this button to refresh the layer list. Here we have the list of all the bands loaded in QGIS. In this case we can click select all selected bands, which are the bands that will be clipped. Then we can use this button here and left click and right click to define the upper left and the lower right corner. So we can define the area that will be used for clipping. So all the images will be clipped according to this area. Also we could change manually, so for instance we can enter here manually the upper left and lower right coordinates according to this tutorial. And then we click this button run, select an output directory, and when the clip is completed we can see that the clip bands are loaded in QGIS. Now we are going to create the input of the classification, which is the band set. So click this button, band set, and in the main interface we have the list of all the bands, single band raster loaded in QGIS. We should check only the clip bands. Here, when we have checked these bands, we click this button to add the bands to the band set, and here we have the list of the Sentinel-2 bands in the band set. We should also order the number of the bands. For instance, we have this band 8A, which should be set after the band 8 and before the band 11. We can use this button to move and order the bands. Next, we should set also the center wavelength. So in the quick wavelength settings, select the Sentinel-2, and as you can see the center wavelength will be set for all the bands. Here in the input image we can see that the band set is defined. In this tutorial we are going to classify these four land cover classes: water, built-up, vegetation and bare soil, similarly to the first video tutorial. Now we are going to create the training input file, so click this button and create a new training file. For instance, training. And here we have the path to the training file. This file will contain both the spectral signatures and the ROI polygons. Now we can also display a color composite of the image. So in the RGB list, select for instance 321, which is a natural color. A virtual raster is automatically created and loaded in QGIS. We can also edit the RGB list and for instance set the color composite 3710 and press enter. Here with this color composite, this is particularly useful for highlighting urban areas, and we can switch between color composites very easily from the RGB list. Also a new tool is the RGB list, which allows for ordering and editing the RGB color composites. So for instance click this button to add a color composite and enter 732, which is the classic near-infrared false color composite. We can also delete color composites. And we can switch from the RGB list also using the mouse wheel. So it is very quick to change the color composite. Now in the classification dock we can see that this option display NDVI allows for displaying the pixel value of NDVI when we click one of these buttons here for the ROI creation. So for instance here we can see that values, very low values, negative values for water, very high values for vegetation. We can also use these buttons here to enhance the contrast and improve the display of the image, actually improving the stretching of the color composite. So now we can create the first ROI. We can click here for the region growing ROI. We can see that a few pixels are now included. We can also change the distance value and redo the ROI. We can see here that these pixels are now included. Next, we set the macro class information and class information for water. And we change the color of the class. Here, for instance, blue. We can notice that the class ID is automatically increased. And also the macro class is displayed in this tab, macro classes. We should also change these colors here for the macro class water. Now we're going to create the second ROI for the class built up. Again, we should use these buttons to enhance the display and the stretching of the color composite. We can see more clearly these buildings with a white roof. Then we are going to create a ROI. We can increase the distance value in order to create larger ROIs. And also if we click different pixels, we can see that the shape of the ROI changes. Or we can create a manual ROI, including more spectral variability in this ROI. So for instance, here, this polygon. Next we set the macro class information and the macro class ID for this ROI. So built up. And the class information. And here we have saved our second row for the class buildings built up. Change the color. And we also change the color for the macro class here. Now we are going to create the third row. We can change the color composite in order to see more clearly built up areas. So for instance here we are going to create a new row for roads. So this color composite 3710 is very useful for highlighting built up structures. And changing the distance values, we can adapt our row in order to select only pixels belonging to roads. So when we are satisfied, we can save the row, change the class information, the macro class is the same, and click Save. As you can see, the macro classes is not changed because we have added a new row with the same macro class built up. We can create another row for another type of built up. You can see here these buildings are different from the previous ones. In this urban area we have buildings and very narrow roads. Change again the distance parameter. So we can create another row here. Again we change only the class ID and the class information. So here, class information, buildings and roads, very narrow roads. We select the color for the class. You can see that if we change the macro class, also the macro class information changes according to the definition of the macro class. Of course, only for the macro classes already saved. We should collect several rows for each macro class, and here you can see the process of collecting several rows for the class built up, vegetation and bare soil. Of course, it is important that these rows are quite large but also quite homogeneous, because we are going to use the maximum likelihood algorithm. And here, after the creation of several rows, we can see that in the right part of the image we have clouds. We could mask clouds in several ways. For instance, we can create rows for clouds. So using region drawing, change the distance parameter. And set the macro class ID 0, which is a special code for unclassified pixel. So here, macro class information we can set unclassified, and class information cloud. It is important to set a unique class ID, like for the other rows, and we click Save. We can see that this macro class 0 has been added, and we can change also the color here, for instance black. Pixel belonging to this macro class will be set as unclassified. After the collection of several rows, we can create our classification preview. We can also set preview size of 500 pixels. And after clicking this button here, click in any pixel of the image. In classification algorithm, select the maximum likelihood algorithm that we are going to use in this tutorial. Click in any pixel of the image. It is important that this process is an iterative process, and you can see that the classification preview for the classes has been calculated. Click this button to zoom to the preview. We can also use this radio button to show and hide the preview, and use the transparency tool. So we can see that this preview has been classified according to the class ID. If in classification algorithm we check macro class ID, we are going to use the macro class code. Macro class. So if we click this button, we redo the preview, and we can see that this classification is performed with the macro class ID. So it's quite different from the previous one for the colors. And now we can create a preview here, and you can see that also if we create a preview where there are clouds, these clouds are unclassified. We have created the previews. We should also assess the spectral signatures, which is important in order to perform a good classification. So highlight the spectral signatures and click this button to display the spectral signature plot. Here we have the plot. We can also move with the left click inside the plot. We can compare this spectral signature of vegetation crop with this spectral signature of built-up. We can show and hide spectral signatures using this checkbox. Here we can see the value range, which is the minimum and maximum values of the ROI. We can also see the signature details here with all this information, and the size in pixels, the number of pixels of the ROI. Here we have the values, the mean values, and the standard deviation of each ROI, which is of course related to the spectral signature. It is important that spectral signatures are distant in order to avoid classification errors. If we click this button here, calculate spectral distances, we can calculate the spectral distances between each pair of ROIs, or spectral signatures. Here we have the Jeffreys-Matsushita distance, spectral angle, Euclidean distance, and Brake-Curtis similarity. These are very important to assess the similarity of spectral signatures. We can also assess the classification disabling one or more spectral signatures. So for instance, we can uncheck these spectral signatures and redo the preview. We can see that this preview has been calculated without the spectral signatures that we have unchecked. We could also use this button to delete one or more spectral signatures that we have highlighted. But now we are going to select again the spectral signatures and redo the preview. Spectral signatures are saved in the training input file every time we click the Save button, the QGIS Save button, which also saves the project. So we should click Save quite often. Now I have collected several rows. Of course, the more is the better. It is important that every class is represented. We can double click on the row signature list to show and zoom directly to every row we want to display. We can use this button to zoom to the image extent. So we are going to create a classification using the macroclass ID and the maximum likelihood algorithm. But before performing the classification, it is important to set this parameter in the tool settings of the plugin. In particular, the available RAM parameter. It is important, of course, to increase this value. You should set a value which is half of the computer available RAM. So for instance, we set 1 GB of available RAM. Then in classification output we can click Run, select an output destination. After a few minutes, the entire input image will be classified. If we zoom here over the cloud, we can see that the cloud area has been left unclassified. Of course, we could also improve this mask of cloud cover with other methods that we are going to see in other tutorials. So we can see here the classification of built-up areas. And also we have some classification errors, for instance here over bare soil. We have also other tools for improving this classification using these post-processing tools. For instance, the tool Edit Raster for editing the raster values directly, and also classification sieve for removing small patches, classification erosion and classification dilation. But we are going to see these tools in other tutorials. So well done, we have completed the second basic tutorial. And the next few weeks I'm going to upload several new tutorials about this new version 5 of the semi-automatic classification plugin. And please join the Facebook group and the Google Plus community. And thank you for watching.